Hi guys, this is the first session, so week 1 number for the AQA Level 2 Further Maths Revision course. From the advanced information, we're given what topics are going to come up within various categories. Paper 1 is your non-calculator, and we've been told we're going to have within number, percentage increase, ratio and surds. And paper 2, we've got some more ratio questions and the product rule. So let's look at percentage increase. Percentage increase, so if I said to you I want to increase a value by 15%, it means I want the original 100% plus the additional 15%, so I'm looking at 115% of the original value. And we're going to think of things in terms of multipliers, because whether it's an increase or decrease, this helps us to calculate things. Now remember, percentage is just a fancy way of dividing by 100. So if we've got 115%, we do 115 divided by 100, which is the same as multiplying by 1.15. So 115 divided by 100 gives you 1.15. This is our multiplier. So if we're finding an additional, so the original plus the 15%, we times it by 1.15. Let's take a practical example. So if we've got something like 50 meters and we want to increase it by 15%. So we could think about it in two ways. We're a non-calculator, remember, revision from GCSE, or from the stuff that you would have done earlier on, is that if you want to find 10% of anything, you divide by 10. So 10% of 50 would be 5. 5% would be taking that 10% and dividing it by 2, so 2.5. So altogether, 15% would be 7.5. So remember, if I'm increasing it by 15%, I'm adding that extra bit. So it's the 100 plus the 15. So that would give me 57.5 meters. This is going to make a lot more sense. We're going to go look at some exam questions. Okay, so question 1. The value of x is 50% more than the value of t. So we're starting off with t. We've got the original 100%. We're adding 50%. So we've got 150%. So my multiplier is 1.5. So I know that 1.5 lots of t equals x. Now I've got the value of y is 10% less. So I've got my original 100%. I'm minusing 10% to give me 90%. When I divide that by 100, I get 0.9. So I know 0.9 of w is y. The next line tells me x equals y. So I can make these two equal to each other. So I get 1.5t equals 0.9 w. I want to end up with t over w and an answer as a decimal. So I'm going to divide both sides by w. I get 1.5t over w equals 0.9. I don't want the decimal on the other side, so I'm going to divide that by 1.5. So I get t over w is 0.9 over 1.5. Decimals are annoying, times everything by 10, 9 over 15. I can cancel that down to 3 over 5, which is 6 over 10, which as a decimal is 0.6. Now you might have got there quicker, your arithmetic could be better, and that's not a problem. Okay, question 2. P increases by 25%. So I've got my 100%, add my 25% to give me 125%. Right, so originally P is 4x. I'm increasing it by 1.25. Right, now we should know 25% is a quarter. A quarter of 4 is 1. If we're taking the original amount, adding that 1 on, we're now going to have 5x. Q decreases by 40%. So instead of adding, we're subtracting. So we end up with 60%. So we're taking our Q of 7x and multiplying it by 0.6, because we're taking that 60% and dividing by 100. So we could do 7 times 6, which gives us 42, There's one number behind the decimal place, so we need to divide it. So 4.2x. We're told that this new p of 5x is 28 greater than q of 4.2. So when we take them away from each other, we get 28. 5x minus 4.2x is 0.8x, which is 28. So then all we need to do is we can do 28 divided by 8. So if you do 28 divided by 8, you're going to get 3.5. But because you've got the 0.8 on the bottom, you times it by 10 and you get 35. So let's double check that arithmetic because we said we might come up non-calculator. 28 over 0.8. One easy way to do it is to times top and bottom by 10. So you get 280 over 8. And then you could calculate that. 28 into 8 is 3, remainder 1. Sorry, not remainder 1. So then we can end up with, so 28 divided by 8 is obviously, let's do this properly, as opposed to me showing you. So we're going to get 3. 3 times 8 gives us 24, so we've got 4 left. 8 into 40 is 5, and we get the 35. Sorry. Double checking you're happy with the arithmetic because you do have the non-calculator paper there. Right, so now let's look at ratios. We're going to look at ratios. Now, ratios are just fancy ways. So if you've got A to B, it's the same as saying A divided by B. So now we've got A to B to C, and we want everything in terms of the same thing. So I'm going to check out A and C. So A to C is 5 to 2. So that essentially tells me A over C is 5 over 2. So 2A is equivalent to 5C. That means 4A's will be the same as 10C's. So we're just going to put everything in terms of C. Could have put them in B's or A's, it wouldn't have mattered. There's no good reason why I chose C, but I think it's going to work out nicely. Hopefully it does. Then we're going to look at B to C. B to C is 3 to 2. So B divided by C is 3 over 2. So that tells us 2B's is equivalent to 3C's. So we have 3B's on the other side. So 1B would be 3 over 2C. So 3B's would be 9 over 2C. So now if we plug that all in, we've got 4A, which we said was the same as 10C's. So 10C minus C equals 9 over 2C, which is the same as 9C to 9 over 2C. And the C's and everything cancel, and we will end up with 1 to 1/2 times both sides by 2, and we get 2 to 1. So 2 to 1 is my ratio, and I've gone through a long way of doing that just to show you the relationships. You may have come to that, it's only 2 marks in one line, and that would have been perfectly fine. Next bit, we're given m double dot n equals 2 to 5. So that tells us m divided by n equals 2 over 5. And we want m in terms of n. So we want m equals something. So I'm going to multiply the n up here, and we're just going to get m is 2/5 n. Now we need that for the next bit, so let's write it up here. M equals 2/5 n. So now we're given a to b, so remember we can write that as a fraction, is equal to 10m over 3n. Oh, we don't actually need to write it as a fraction, but never mind. Right, now we want to get rid of essentially the m and the n's. But let's see what we know. We know that m is equal to 2/5 n. So 10m will be 10 times 2/5 n. That's going to cancel and give me 4n. So now we've got a over b is 4n over 3n. We can cancel out the n's, and we can see a to b is 4 to 3. So our answer will be 4 to 3. Okay, rationalising a denominator or a surd, rationalising a surd. We do not like surds on the denominator. So on the bottom, as mathematicians, we like everything clean and pretty. So to get rid of a square root value, we square it and we get whatever was underneath. However, if we have more than one thing underneath, so we want to get rid of it, we need to use the difference of two squares. So for example, if we've got root a plus b, we need to multiply it by root a minus b. And what that will do is we'll square the first number, which in this case would be a, always a minus the second value squared. And that's typically the questions you're going to get in further maths. You're going to have, very unlikely you'll get just a single value. You'll probably have to use the difference of two squares. Excuse me. Right, so we've got root 3 minus 7 over root 3 plus 1. We're going to multiply top and bottom by the same thing on the bottom, but instead of a plus sign, we're going to have a minus sign there. Root 3 minus 1. All right, so let's open that out. We've got root 3 times root 3, which is just 3. Root 3 times minus 1, so minus root 3. 7 times root 3, so minus 7 root 3. Minus 7 times minus 1 to give us plus 7. All over root 3 times root 3. Now this is the difference of two squares. So looking at this example here, so that's going to give us 3 minus 1. All right, let's simplify everything. 3 plus 7 gives us 10. Minus root 3 minus 7 root 3 gives us minus 8 root 3. All over 2. We can divide everything on the top by 2. And we get 5 minus 4 root 3, which is in the same form as we're expecting it. So let's have a look at another example. It tells us to simplify fully. Now I look at that and the first thing I'm going to go is root 300 seems a bit big. Let's see if we can simplify that. So that's the same as root 3 times 100. Root 100 is 10, so I get 10 root 3. So now I've got 24 minus 10 root 3 over 4 root 3 minus 5. And we want to rationalise that denominator. So we're multiplying top and bottom by 4 root 3 plus 5. Okay, so we've got some big numbers here. Now to be fair, this question was actually in a calculator paper, but there's no reason you shouldn't be able to do the mental arithmetic for it. You've got 24 times 4 to give you 96 root 3. 24 times 5, and if you want to do that quickly, think to yourself 24 times 10 is 240. And then what you want to do is you want to half that. So you get 120. So plus 120. Minus 10 times 4, which is 40, times by 3 to give you minus 120. Minus 10 times 5 to give you minus 50 root 3. And on the denominator, you're going to square the first number. So you've got 4 root 3 squared, which is going to give you 48 because it's going to be 16 times 3. Minus 5 squared, which is 25. Right, so let's clean that up. The 120s cancel. We've got 96 minus 50. So we've got 46 lots of root 3. And then we've got 48 minus 25, which gives us 23. That cancels and gives us 2. So our final answer after all that work is just 2 root 3. The final topic that we're going to look at is the product rule for counting. Now the reason it's called the product rule is that product means times. So you're multiplying all the different possible outcomes, okay? So your product essentially means multiply, and you're looking for all the different outcomes. So let's have a look. Our first question asks us how many odd numbers are greater than 30,000. So that's our important bits of information. We want it to be an odd number. Okay, so an odd number can't end in an even number. So that rules out 2, rules out 4, rules out 6, and rules out 8. So our last value, the only possibility is 7, okay? We want it to be greater than 30,000, so my first value can't be smaller than 3, so we can't use 2. So the only options are 4, 6, and 8, because remember 7's been used up. So my first value has 3 options. My second value can be any number except for the 7, so that rules it down to 4, and except for the one I just used as my first value. So there's only 3 options. So now those 3 options left over, one of them can be used for the third value. There's only 1 left for the fourth value, and there's that 7 there. So we get 3 times 3 times 2 to give us 18 possibilities. The final question, which is also on the product rule, you're looking at digits 2, 4, 5, 6, 7, and 9. You want them to be greater than 60,000, nothing is repeated, and an important bit of information here is you're using some or all of the digits. So we're thinking how many integers can be made? Now, we could have all 6 digits, at which point it doesn't matter what the first value is. So if we look at 6 digits, you could choose any number, because even if it's 2, it's 200,000, which is bigger than 60,000. So here we've got, could be any of the 6 numbers. The next one is any of the 6 except for the one you used to begin with. So that's 5, and then 4, then 3, then 2, then 1. And so this is a calculator paper. This is actually called a factorial, but you could type it into your calculator. So you do 6 times 5 times 4 times 3 times 2, and that would give you 720. Now, if we were to use 5 digits, we want it to be bigger than 60,000. So the only options for the first number are 6, 7, and 9. So we've got 3 options for the first number. For the second number, it can be any of the 6 except for the one we've used to start with. So we've got 5 options. And the same for the third number will follow suit, will be 4 digits. The fourth number will be 3, and the fifth number will be 2. So we end up with 3 times 5 times 4 times 3 times 2. So 360 possibilities. So the total will be 720 plus 360, which gives us 1080. So we've got 1080 possible solutions. Hopefully that makes sense, and I hope this has been useful. Don't forget to subscribe, to let me know in the comments what you think, even if it's a thumbs up, yes, or I'm not sure, you didn't spend long enough, whatever it might be, and we'll see whether we can help.